All right, welcome back. We are going to cover some variation. It should be a very straightforward video. I think you'll find this to be really nice and a breath of fresh air considering all of the very challenging topics we've been doing lately. So, okay, let's check it out. I have some word problems already thrown into a Word document, and two of them are actually from our homework assignment. So hopefully when you see it, you'll be like, okay, this is not a big deal. I've already seen this. Dr. Santiago went over it with us. So let's take a look and see what you think. All right. So I'm going to share my Word document here, and let's talk about variation. So there are two types that we're going to deal with in this class: direct variation and indirect variation. When you think about direct variation, I want you to think as if you have two variables, x, y, as x increases, y increases, as x decreases, y decreases. So that's direct variation. They're related to one another. But there is included this constant of variation, and we call that constant of variation k. So I'm actually going to make a note up here that when we see that letter k in the variation, we're actually referring to a constant of variation. But let's take a look at the formula that comes with this. So for instance, if I said that, for instance, y varies directly as x, then what I'm saying here is that y is going to be equal to some constant of variation multiplied by x. So I want you to think direct variation, straightforward, it's in a line, you don't have to worry, there's nothing fancy going on here. With indirect variation, I want you to imagine I'm saying something as y varies indirectly. Oops, can I type? I can do it. Indirectly as x. And in this case, it's slightly different. So we have y is equal to, and instead of being direct and straight in a line, as you see, y and x are directly on the exact same line. It's almost like if I drew an arrow, you would see y connecting to the x, right? But with indirect variation, you actually now have a fraction. So notice that y and x are like in opposite locations, numerator for denominator. So what's happening with indirect variation is as x increases, y decreases, or as x decreases, y increases. So they have that relationship, but they're opposite relationships. And that's essentially what's happening here. But I want you to notice that even in this case, you still have your constant of variation. So I like to draw kind of like arrows that show, and I could try to do this by hand. This might be a little bit crazy, but I want you to think of, yep, I knew it was going to be crazy. So we left to right, that's direct variation. And then I want you to notice that we have this diagonal here. So y varies indirectly as x. So I want you to think that the x is pulled to the denominator. So let's actually see this in action. So problem number one. If y varies directly as x and y is equal to 6 when x is 15, time out, right? We don't go any further. We were given y and x, that pair, which means we can solve for the constant of variation. So that's actually where we're going to begin. So let's go ahead and input our values. We know that because y varies directly as x, our formula is y is equal to k times x. We're now going to substitute our value for y, which was 6. We don't know what the constant of variation is, but we do know x. X is 15. So in this case, we say to ourselves, well, I know how to solve this. I can get k by itself by dividing by 15. So if I go ahead and I divide both sides by 15, I have that 6 over 15 is equal to k, which you know you wouldn't accept as an answer. So we're going to say that that actually in reduced form would be 2/5. Oh, I can type. I swear I can. So, and it's 2/5 because we're dividing by 3. 6 divided by 3, 2. 15 divided by 3, 5. So we see that the constant of variation is 2/5. Now let's keep reading. Now it says find y when x is 2. So the first piece of this equation gave us the value of k, our constant of variation. So that's our good point here. This is the information that we need to use to help us to find additional information. So notice again, we have our equation. So y varies directly as x, but this time we don't know y. which is totally fine, but we do know K, and that is 2/5, and we do know X. The value of X is 2, because it says find Y when X is 2. We go through the motions and we see that Y is equal to 2/5 times 2, no big deal. That's going to give us 4/5, and we've solved, and that's it. That's direct variation. Let's take a look at an indirect variation problem. Y varies inversely, Y varies inversely as X, and Y is equal to 8 when X is equal to 5. Pause right there. Let's write our formula. We have that Y varies inversely as X, so inversely you're thinking denominator, okay? So Y is equal to K over X. X is now in the denominator, varies inversely. We do know the value of Y. We're told that Y is 8. We don't know the coefficient or the constant of variation, so K, but we do know that X is 5. So let's solve this. You know how to solve. This is a proportion. We can cross multiply, or we can take each term and multiply it by the LCD. In this case, our LCD is 5. So if I multiply both sides by 5, I find that 40 is equal to K, right? And that's the same thing as cross multiplying. 8 over 1 equals K over 5. 8 times 5, K times 1, 40 is equal to K. We now take that piece of information and we say, find Y when X is 4. I'm going to rewrite the equation for Y varying inversely as X, and now I'm going to substitute my values. I don't know the value of Y, I leave it Y. Now I know the constant of variation, that's 40, and I know that X is 4, so I input my values. 40 divided by 4 is 10, and there's your solution. Let's take a look at an example ALEKS problem. On a given planet, the weight of an object varies directly. So this is actually really important to us. So the weight of an object, if I had to decide, I'm probably going to use W for the weight of an object. And it says varies directly with the mass of the object. So again, I'm using letters that are associated with what I'm trying to find. So let's start with the equation, just the general form. So the weight of an object varies directly as the mass of the object. Boom, there's my equation. Weight W, M, mass. Suppose that an object whose mass is 5 kilograms weighs 45 newtons. Okay, let's plug it in. I know that W is 45. I don't know the constant of variation, but I do know that the mass is 5. We know how to solve that. You divide both sides by 5. 45 divided by 5 is 9. And we just solved for K. We then consider, all right, I know what the equation is for this particular problem because we're still dealing with direct variation. But this time it says calculate the mass, so we don't know M, of another object that weighs 36 newtons. So we're going to go ahead and replace W with the weight, which is 36. We know the constant of variation is 9, but we don't know the mass. It's asking us to find the mass. If you were going to go ahead and solve for M, you're going to divide both sides by 9. And if you do that, you find that the mass is 4. And more specifically, we can say that the mass is 4 kilograms. I hope this is pretty awesome to you. This is a great section. Let's look at number 4, last problem. The time it takes to cover the distance between two cities by car varies inversely. So this is incredibly important to note with the speed of the car. So the time it takes to cover the distance varies inversely with the speed of the car. So time and speed. So let's go ahead and write out a formula for this. So I'm going to use capital T for time, and it varies inversely with the speed. So I'll use S because I'm writing this out on the computer, so it doesn't look like 5s. It's an actual S, okay? All right. So we are told that the trip takes 9 hours, time, for a car moving at 22 miles per hour. So I don't know the constant of variation, but I do know the speed is 22 miles an hour. Again, notice we're faced with a proportion. We can simply cross multiply to actually get those values. So if you think about cross multiplying 9 times 22 and then k times 1, we find that k is equal to 9 times 22, which is 198. There is our constant of variation. So again, let's go ahead and write out the formula as is. T is equal to k divided by s. Time is equal to the constant of variation over speed. Now it says, how long, okay, that means I don't know time. How long does it take for the car moving at 18 miles an hour? So we know the constant of variation is 198. And we know the speed of the car is 18 miles an hour. By the way, can you imagine driving 18 miles an hour? Ugh, just take me out of it. So then we have time is equal to, we've got 198 divided by 18, and we find that time is 11 hours, and that's probably because you're driving at a snail's pace. So I feel sorry for you. Maybe you're driving in a blizzard. I don't know, because we don't deal with that in Florida. Excellent. Well, have a wonderful rest of your day, and I hope that this video is very helpful for variation. Bye.